My name is Alex Dykstra, and I'm going to be presenting Group 50 Star Search Simulation project. And this is with the other members of my team, Jared Craddock, Jen Hepp, and Tori Mercurio. Just an overview of what this video is going to entail is we're going to talk about the changes to clients' requirements, how to use the program, and then also I'm going to demonstrate some of those changes. So just beginning with what has changed to our client's requirements is that we've added a GUI, so a graphical user interface. In that interface, we are going to be displaying the space region and its occupancy, which includes suns, drones, explored and unexplored squares, and then also an additional battleship, which we'll get to talk about later. You will also be able to see the initial parameters of the simulation, so that's the size of it, the number of explorable squares, and then also you'll get some current statistics of what drone is active, the orientation of each, the number of explored squares, and then the number of completed turns. We're also going to provide a next button, which selects the next active drone and chooses an action for it. We also have a fast forward button. Each action is going to be turn by turn until the simulation terminates. And then we also provide a stop button, which ends the current simulation. We have a new button, which will allow for the selection of a simulation file. And then you'll be able to resume a stop simulation and display the final report after the termination of the simulation. Our second modification to client's requirements is that upon exiting the application, the current state of the simulation will be saved, and that saving is going to happen on disk so that a client can either pause a simulation and come back to it later, or if something were to happen, it will close out and get saved. So that's going to be mostly in the background, but we'll demonstrate that. And then finally, we are adding to the client's requirements realistic editions of other spacecraft or objects. We are adding one called the Battleship. It is slow moving and it is like a drone in that it moves, but it can only move one square per turn. It can also scan in order to find other objects in space, and it can, what is actually different is that it can shoot and hit objects, specifically drones, up to 2 squares away from its current position. It can only shoot in the direction of its line of sight, and it also can be destroyed by suns just like the drones can. So these battleships, which are like drones, can move around and basically target and destroy drones. So just another obstacle for the drone to overcome. So I'll talk about a little bit how to use the program, and then also at the same time demonstrate some of the changes. So in order to use the program, you're going to just be on our desktop of the VM image that we give you. On the desktop is a file. If you double click it, it's called Star Search. And when you double click it, it's going to open up our Star Search simulation application. And it'll take just a second. Okay, once you've got the application open, you can see the graphical user interface with a lot of the buttons that I was talking about, along with where we're going to see some of the statistics show up, along with an exit button, etc. When you run the program, when you want to load a new scenario for the simulation, you're going to click on the new button. It's going to bring you to a directory where there is a file called scenario, or a directory called scenarios. Go ahead and go in there, and we've included 5 scenarios that we thought were pretty interesting and showed some of the new abilities of the client's requirements and its implementation. So we'll go ahead and look at scenario number 1. Once you open that, it's going to load, and as you can see, this is the user interface of it. So we have just a grid with rows and columns, and then those are also numbered so that you can actually see where things are. Basic running of the simulation includes iterating one at a time over each drone's, specifically the drone whose turn it is, move. So if we hit next, the first drone up is going to be our D0 is the ID of that drone. And as you can see, it has crashed and it is removed. Because the drone occupies a square with stars, that those stars actually counts as an explored square. And as you can see the current number here in the top right. So explored squares is 3. So under each one of these drones, there are no more stars. So you can continue on showing each one. You saw another move, saw another crash, and also another crash of a battleship. And their IDs start with a B. If you don't care to go turn by turn, you can hit this fast forward button. And what that's going to do is going to continue the simulation until it's complete. Upon completion, the final report will get printed out, and this is the same information that was required in the client's first set of requirements. So once you do that, what you can do is you can go open another one, and I'll demonstrate a different behavior of it. If we go look at scenario 4, let's open that. Pretty complicated one, pretty dangerous one. As you were able to see on the other simulation, these battleships move, and we can see that they make decisions, just like the drones do. Let's go to a bigger one so I can show you that. Not the one I was looking for. Okay, so here's a bigger one, and we can kind of see moves happening more and maybe get to see how the battleship actually moves throughout. So we'll go ahead and fast forward this, and we will see drones moving. We'll also see the battleship moving, doing turns and exploring. One special thing to note about the battleship, and this was some complications in the client's requirements, is a drone is actually occupying stars. As you can see, it just moved. Underneath it, there are actually stars, so a drone can't even explore if there's a battleship sitting on the set of stars. But once the battleship moves, those stars will come back and the drone will be able to explore it. And as you can see, it's approaching closer to the drone. So we'll go ahead and stop it, and you'll see that the final report gets printed out. And to demonstrate the saving ability, the persistence of the application, I'll open up this first one. We'll go move a couple times. As you can see, they're just scanning at this point. So we saw some movement over here, some turning of other ones. When you go and exit the application, it's going to say, are you sure you want to exit? And then it will also tell the user, incomplete simulations will be saved. So if you hit no, it's just going to keep you where you're at. But if you hit yes, the application will actually close. And what we can do is we can go open up the application again. And we can see that a button is now active, which upon the first time running this and never exiting, the button actually was not available. So we'll just wait a second for it to load. So now we've got this resume button up here. We can click on it, and it's going to bring us exactly to where we were. And you can continue the simulation as is. And we can see everything's going to work normally. Drones are doing pretty good. That battleship usually gets most of them. Okay, so it ended, and we can see the final report prints out. So that persistent state just saved upon exit. And it only happens when a simulation is in progress. So it won't happen if you're already done with the simulation. And that is really it of the application and the client's requirements. Again, we had three modifications, one being the graphical user interface, two being the data persistence, and three, the addition of those battleship objects. Again, my name is Alex Dykstra, and I'm presenting for Group 50. Thank you for listening.